All right, 8.6 day 2. Solving log equations, or logarithmic. And we're going to start off with something we learned the first day that we talked about logs. The first day we said log base b of y equals x if and only if, and we said b to the x is equal to y. Remember, we talked about how just log is just another way of writing an exponential form, right? But then there was also some fine print that I gave you. I said that b cannot be 1 and y has got to be greater than or equal to 0. All right, and I told you that it wasn't going to be a big deal for a while, and now it's going to be kind of a big deal. Here's what's up. Why can't b be 1? Let's think about that. If I have log base 1 of 9 is equal to something, right? Well, if I was to rewrite this, this would be 1 to the what power is equal to 9, right? That's what this would be in exponent form. Well, 1 to the what power, even 1 squared, 1 cubed, 1 to the 87th power is always 1. Even negative exponents, 1 to the negative 9 is still 1 divided by 1 to the 9th, which is still 1, right? So here's the thing. It'll never be 9, even if it's a fraction. 1 to the 1/2 is still root 1, which is still 1, right? So here's the thing. That's why the base, b, can never be 1, because that will never happen. All right? So that's the first thing. How come y's got to be greater than or equal to 0? Well, let's talk about this. If we have log base 2 of negative 9 is equal to x. All right, let's talk about that. If we have log base 2 of, I should put parentheses around that, negative 9 is equal to x. So if we were to write this in exponent form, this would be 2 to the x power is equal to negative 9. So think about that. 2 to the what power is negative 9? Well, if we were to graph that, or even just think about 2 to the second, that's 4. If we go higher and higher, it's only going to be bigger and bigger, right? So it's going to be a negative maybe, right? 2 to the negative third is 1 divided by 8. 2 to the negative 100th is 1 divided by 2 to the 100th power, which is still positive, right? So what the moral of the story is that an exponent will never make 2 be a negative number. Right? We would have to multiply it by a negative number. So that's why y's got to be greater than or equal to 0, or y cannot be negative. All right? What it's saying here is that, well, that's why y cannot be negative. It's saying that this is never going to be negative. All right, so let's do a couple of examples here. We're going to keep solving. Number 1. Log base 3 of 5x minus 1 equals log base 3 of x plus 7. All right, so this is an easy one. Hopefully it makes sense to you. Log base 3 of this equals log base 3 of that. Does it make sense that this is equal to that? Sure. So solve that really quick. You should get 4x is 8, x is 2. All right? And we could check our answer, right? Plug it in. 5 times 2 is 10 minus 1 is 9. 2 plus 7 is 9. Log base 3 of 9 is the same thing as log base 3 of 9. Perfect. Here's where it gets a little bit trickier. Number 2. How about log base 4 of x plus 3 equals 2? Now, here we had logs on both sides. Here there's only one log. And we talked about this briefly once before. What is the enemy of log base 4. The enemy of log base 4 is base 4 raised to the power of log base 4. So you're going to base 4 both sides. So what this becomes is 4 to the 4 and the log 4 cancel. You're left with x plus 3 equals 16. 4 squared is 16. So therefore x is 3. Do a quick check. Put in 3. Or excuse me, not 3. 13, my bad. Plug it in. 13 plus 3 is 16. Check it out. 4 to the second power is 16. All right? Here's where it's going to get weird. Number 3. Log of 5x plus log of quantity of x minus 1 equals 2. That double log is freaking me out. I don't like that. So here's the thing. We're going to condense this and only have one log. That's the whole point why we did that a couple of sections ago. So if we were to use the log properties, this is plus, so that means this is going to be log of 5x. I'm going to multiply that by x minus 1. And I got brackets to say it's the log of that whole thing. 5x times that is equal to 2. All right, so now it's just like number 2 here. This is log base. What's the base on this log? The base of this log is 10. So what's the enemy of log base 10? Base 10 both sides. You're going to base 10 both sides. So 10 to the log base 10 cancels. You're left with 5x squared minus 5x equals 10 squared is 100. Uh-oh, we got x squared and x we're going to have to factor. So this is 5x squared minus 5x minus 100. Get it equal to 0 first. Let's see if this factors. Now to factor, the first thing you always look for is GCF. 5x squared minus x minus 20 equals 0. We get 5 times x minus 5 times x plus 4. All right, well, multiplies negative 20, adds up to negative 1. So that means that x is 5 and negative 4. Those are our two solutions. Right? But here's the thing. Let's go back and check our answer. If we go back and check our answer, 5 times 5 is 25. 5 minus 1 is 4, so you could put that in log of 20 plus the log of 4, and I think you'll find that it's 2. If you want to go ahead and check it, go ahead. But here's the problem with negative 4. Log base 5 of log of negative 20 cannot happen, right? Check it out. We can't have log of negative, log of negative 20, right? That goes back to the whole thing. The base here is 10. 10 to the power of x will give us negative 20? Nothing. Nothing gives us a negative. So here's the thing. If it makes what's after the log negative, this is not a solution. If you plug in, even here, negative 4 minus 1 is negative 5. If you plug it in and it makes it negative, it's not a solution. So there's only one solution here. Solution here is 5. All right, let's do a couple more. Number 4 is log base 5 of 3x plus 1 is equal to 2. How do you unlog base 5? Base 5 both sides. So I got 3x plus 1 is equal to 25. Go ahead and solve that. I'll race you. Ready, go. I did that. Who won? Did I win or did you beat me? Well, hopefully you got 8. But does 8 work? Plug it in. 3 times 8 is 24, plus 1 is 25. 5 squared is 25. That seems to work. One more. Let's try this one. How about Oops, number 5, right? Log base 4 of 5x minus 11 equals log base 4 of 3 minus 2x. So here's what's up. This is kind of like that first one, right? Log of this is equal to log of that. It makes sense that this is equal to that. Or think of it this way. If this is log base 4, how do you unlog base 4? Base 4 both sides, right? So 4 raised to the log base 4 cancels. You're left with 5x minus 11 equals, that cancels as well, 3x minus 2x. So solve this. Again, I'll race you. Oops, I screwed it. You're going to win. Oh, that's not an x. That's why. I goofed up. So yeah, hey, if you're stuck too, it's just a 3, not 3x. I goofed up. So this is going to be 7x equals 14. X is 2. Right? Awesome. All done. Well, let's check our answer. We plug this in. You get 5 times 2 is 10 minus 11 is negative 1. Log base 4 of negative 1 can't happen. All right? If you get a negative, can't make it work. So this is no solution. So with logs, you solve it just like we always do, but you got to make sure to go back and check it. If you plug it in and what's inside a log parentheses is negative, it can't work. Otherwise, it works just fine. Smith out!